Hello. Here we are again for another Project Euler problem. This time we're going to do number 21, which is all about amicable numbers. It just gives us the definition of an amicable number, and it says here that d of n is the sum of the proper divisors of n, so that's a divisor of n that's strictly less than n, and a number is said to be amicable if the sum, or like numbers form an amicable pair if the sum of the divisors of one is equal to the sum of the divisors of the other, and those numbers are not equal to each other. And it gives us an example, as always, which is really useful, and all we have to do is work out the sum of all of these numbers under 10,000. So because it's like a relatively small amount, I imagine we can sort of not be too worried about performance. So this splits down into a fairly obvious subproblem, I think, which is to get the sum of the proper divisors for each number. So let's just write down that as a function name. So like this, and then n is our number, and then I always use iterators, as if you've watched any of these videos before, you know that's basically all I can do. And then we're going to go from 1, and then there's probably some micro-optimization with like using square roots and whatnot. It's what you usually do when you're trying to find divisors, prime factors, that sort of thing. But I'm just going to go ahead and go with, just because I think it'll be fast enough, n over 2 plus 1, just because I know that once you've gone past the sort of complement to dividing by 2, you're done. And then we are going to filter them such that, I guess these would be divisor candidates or something. Divisor candidate such that the divisor candidate such that n, the remainder, when divising by the divisor candidate, is 0. So that should get us the the sum of the proper divisors of a number, and we can test it on the ones that it gives us in the example, which I think was like, was it 220 and 284 or something? I'll be shocked if I remember that correctly, but let's see. Oh, no formatting required. How about that? Yeah, it just gives us iterators because we've not summed them, which is fair enough. And I would have spotted that if I'd done my good practice thing, which I always tell everyone to do at work, but never do it when I'm solving these problems, which is put your return types on stuff. It makes it way easier to read. Okay, so that's great. So next, we have to, I guess, iterate through all of the numbers below sort of 10,000. So again, we'll use iterator.range, starting from 1 and going up to 10,000. So I'm just going to go ahead and double check that the end of this is, so that goes to end minus 1, as it says here, and that's what we want. We want stuff that's strictly less than 10,000. And also with Scala, you put these little, this little underscore, so it's big numbers, makes it look real nice. Okay, cool. And then we've got to filter them somehow, and we only want to keep the ones that are amicable. So how do we know if something is amicable? Well, and I will, take my own advice and add the return type. So a number is going to be amicable if when we sum its proper divisors and sum its proper divisors again, we get the same thing back. And that's going to be equivalent to this whole sort of like, you can imagine sort of, if I did this using maths, I can imagine wrapping a sort of another d around this d of b. So you'd have d of b equals d of a, and d of a is b from the same equation. Therefore we need, the condition is that b is equal to d of b. And it also says that, it also says a must not be equal to b. Okay, that's not something I've accounted for, right? I will do that in a sec. I will actually no. Let's do it now. So I guess I would say that a is equal to n, just use the same language that's used in Project Euler, and I would say that b is equal to the sum of the divisors of a, kind of by definition, and we require that a is not equal to b, and that the sum of the proper divisors. I just don't want to call this too many times because calling this is expensive, right? So I'm going to say that we do sum of the proper divisors of b has to be equal to a. Okay. So what we can do real quick is just check this on the example numbers. So one of them was 220. So let's try it, and that is true. Let's try it for 284, and that is true as well. And then let's do the whole. So we've already got the filter, which is great. And then we have to sum them, and that should give us the answer. Okay, so that's not a lot of code, right? And like, I guess, well, let's run it and see if it's right, and then I'll talk about what I don't like about this solution, assuming I've got it right, which, you know, let's see. So, let's pop this in here, 62672, and that is not correct. And also, I thought Project Euler told you if your answer was either too big or too small, but I think that might be advent of code instead. Okay, well, something's up in it, so maybe what we need to do as well is... Okay, so I have said that a equals n, b equals, I guess, d of a, which is true. So maybe I really do need to check the other way around. So let's just add that condition in as well. But I would have thought that it would be sufficient to... Oh, look what I've done. I just need to not do that. And actually at work, what we have is this plugin called Zero Waste, which, this one here, which is fantastic, which gets rid of, like, see, I made a very small contribution to it, but what this does is it will stop you from having, like, these discarded expressions like what I just had there. So if I just go back, it would have caught this line and it would have said, well, this is non-units because this is obviously a boolean, and it would have stopped this from compiling. So that's the thing. So I think it should be sufficient to do this. But yeah, this is incredibly useful. And yeah, they're pretty good with, like, when new Scala versions come out and stuff, they're pretty good with updating it. Alright, cool. So that's a different number, which is good. Which means that this a not equals b is doing a ton of work, so I think I'm maybe interested in ones where a does equal b, and I might have a look at that later, but anyway, let's see, so 17951. Okay, the confirmation I probably just left it too long, didn't I? Or typed it out wrong or something. 38506. So that's correct. That's correct. Good. Cool. So I'm going to talk. What am I going to talk about? So I was going to talk a bit about why I don't like this. I think this is being used too much because really I should cache it. But as you can see, this basically runs in a quarter of a second, so I'm not too bothered. Other stuff like this could be way more optimized if I wanted it to be. And there'll probably be something on Wikipedia that just tells you, like, oh yeah, this is like the way to get divisors. but I just wanted something quick and nasty because this is just meant to be a relatively short video. I was going to talk about something. Oh yeah, so I was interested in, well, what's this condition doing? Is that anything interesting? I mean, probably not. But if I do this, so let's print line all of those. See my prime numbers from another project Euler problem. And then I will require that a equals b, because I just want to see what sort of numbers this happens for. Is there anything special about them? Nah, not really. I mean, they are perfect numbers. They're perfect numbers, I think. Yeah. Because that would make sense, right? Because an amicable number is like not as good as a perfect number. So it's when its divisor sum to itself. Yeah. Okay, so that's why that condition was neat. Yeah. Okay. I just recognise the first 3 of those, I guess. And I think Veritasium has a video on this. Yes, he does. Okay. Right. I'm linking this in the description for sure. Okay. Anyway, we have got through another one, and I've gone on a bit of a tangent, but I enjoyed my tangent. I'll reset this back to the right answer for when I commit it to thingy GitHub. And yeah, I'll just check that that's 3,000, 31,000, whatever it was. Yeah, that's correct, isn't it? Okay, cool. I will see you next time. Thank you for listening and watching. Goodbye. Bye bye.